Hello, everyone, and welcome to my channel. This is Sohini from South Bay, California, and I welcome you today. So for everybody who's new to my channel, this is where we talk about everything AI. And as the last video of 2021, I really wanted to thank everybody who has joined on my journey. Everybody who has posted questions, comments, and, even helped each other out in your fascinating projects that you keep, working on every single day. I'm really grateful for all the queries and all the questions that you ask me on LinkedIn or Instagram or through the video comment section as well. And I really hope that we continue to build this platform in 2022. So I am currently actually working about a workshop that I wanted to host in early 2022, where some of the subscribers can actually post some of the content that they're working on, and we get to all learn about what is the fascinating AI-based projects that you all are working out throughout the globe. So I wanted to really wish health and happiness to everybody who's watching right now. I really hope 2022 opens new doors for everyone and we all get happy and healthy sooner. As the last video for 2021, today's video's topic is responsible AI or trustworthy AI. So, with so many, myriads of papers being published on archive every single day, and so many new algorithms, hitting the racks in GitHub or, open source code, which ones have really taken the time to assess all of the situations that can go wrong? So what are the ways in which we can make AI less flawed? And how can we ensure that the algorithms that we are putting into production are actually going to be beneficial and not going to, see pitfalls? So that's the topic for today's video. If this is of interest to you, please, please, please do give this video a thumbs up and subscribe to this channel. So here is today's topic on responsible and trustworthy AI. And in order to really understand what are the components that really construct a responsible and trustworthy AI, I wanted to show you what it is to learn from AI failures so that we understand what went wrong and what should have been done in order to fix it so that the system would be failure resistant and also scalable in the process. So let's get started. So first off, let's start looking at the components of a responsible AI system. The first and foremost is it should be free from bias. Now, ideally, there are 6 to 9 different categories of biases. And again, there's a very good Google resource that I'll be putting in the description box below that lists each and every one of them. But bias typically happens is whenever you have not accounted for all the different categories of samples that can actually happen. So all instances have not been accounted for, and you have really given few instances more weightage than the others. The second one is explainability. So is your model explainable or not? Let me give you an example. So if you're looking at medical imaging, we often are looking at classification. So we are looking at an image and trying to see if there is pathology or not. But can you find the heat maps that is telling you what are the regions of interest because of which pathology exists? Or if you're trying to locate people in outdoor images or cars in outdoor images, again looking at the heat maps in order to understand this is the reason why a pedestrian is located in this region, or this is the reason why you expect a pedestrian to be crossing the road at this particular time or not. Typically what can happen is some models, they are so complex that explainability becomes tough, and in these cases, always the rule of thumb should be choose a more explainable, less complex model over less explainable and more complex model. I have videos on Lime and SHAP features that can really help data scientists explain why a model is behaving in a particular way or not. Then there's TF Explain, and even PyTorch has so many explainability components to them. So always use those explainability components in your work so that you can understand and really analyze outliers. Are they really outliers, or was it just an outcome that you had missed? So explainability is super important for responsible AI. And finally, this is a key component of a responsible AI system that you will not find in a lot of resources, which is contextual. Is the outcome that you're looking at, does it have the correct context? And context mining is actually one of the hardest things to do. I'll give you an example. So let's say that you have created a pedestrian detection algorithm. So whenever there's pedestrians, an autonomous drive system is supposed to avoid that. But let's say that you have a huge hoarding on a highway, and then there is pictures of people on it. So ideally an object detection system is going to detect those people that are in the hoarding and ask you to move away from that particular direction. But that's a false positive, right? And here, if your system had been trained to mine for billboards, and then also being told that if there are people inside billboards, then they should be not considered as pedestrians, then you would have had an ideal bias free and explainable and contextual object detection algorithm that is actually accurate. So the underlying conditions, that where is this person located, is it on a hoarding or is it on a billboard, that creates the context, and that eliminates a lot of false positives and a lot of errors that riddle these autonomous systems. Now let's look at some of the common biases in AI. And this is again a great resource. All these links will be in the description box below. And this is a crash course on fairness and the different kind of biases as released by Google. Now, again, like I said, there are many more, but the more common ones is what I am showing you in this video. So first off, there is selection bias, which is riddled by representation errors. Now, what happens is, let's say, for an example here, if you're looking at, insurance premium. So you've gone and you have surveyed most of the people in a particular area, but there could be, people who have lesser income who you have not surveyed. Maybe they were not home, because of which now your bias is actually riddled into the data that you've collected, because you do not have the complete data. There are a significant number of people who have lesser income who would now, if you had just, created a model out of the data that you've just recovered, it is going to be a flawed model, because it is, maybe it'll increase the premium for insurance for all the people, and the people who have, less salaries will now suffer because of this. So this is a good example of representation errors. And in this case, the solution ideally is boosting or outlier detection. So let's say that in the same insurance premium example that I just gave you, let's say there were a couple of, one or two houses that you did end up getting some data from about their income. So now if you boost their voice, 10 times based off of, if you know how much, population density there is in that particular area, then you might actually get a good picture of what is actually happening in that particular area. Or detecting outliers and trying to understand, using your explainability, is this really an outlier, or should we actually end up boosting, the voice of this particular sample? Because outliers should be eliminated, but if it's a really important sample which needs to, be boosted, then the treatment of both have to be separate, right? So that's the reason why in selection bias, cases, you really have to analyze at these, one or two samples and understand, are these outliers that should be eliminated, or are these key sample points that have just not been represented enough, right? Then there is sampling bias. A sampling bias, a typical example is if you go to, let's say, any platform that has reviews from people, you will see that negative reviews are way more than positive reviews. And this goes to the human nature, is if we really we dislike something, we will go to a particular platform and write about it. However, if we really like it, we'll forget about it. So that's the reason why, positive comment or positive feedback is very less common, than, your negative feedback. So, but does this mean if a particular product has 5 negative feedback and 0 positive feedback, does it mean it's a bad product? It doesn't really mean that. It just means that your way of scoring should not be just based off of the qualitative, outcomes of every single review, rather than a thumbs up or a thumbs down, or maybe a, star process would be a good way to rate a product in that case. So again, in this case, feature engineering, and again maybe boosting, because even if you have one positive review, understanding that one positive review is probably you can boost that 10 times, because there might be 10 people who are not going back to the platform and writing that positive review. So these could be some ways to cater them. And then finally, this is a group attribution bias. And group attribution bias is actually very common. And a typical example is resume screening. So recruiters, if they are asked to look for certain keywords, and they might look at some universities and take them, favor them a little bit more than some other universities that they have probably not heard of. So automated resume screening has actually been shown to really be riddled with group attribution bias, because they are only looking for keywords that they know of, and it's more of an automated system than really AI. So it's really not learning from the system, but it's just executing on a particular rule that has been already set for it. So in this case, outlier analysis and contextual learning really helps a lot. So there might be a candidate from not a very prestigious university, but they may have written papers, but they may have done significant amount of work on Kaggle. They may be Kaggle masters, or they have GitHub, and everything looks great and polished. So again, that kind of candidate actually stands out. So that needs to be given merit over just looking at what university they come from. So in these cases, there are methods to make sure that the system that you've created, that you're putting into production, is not riddled with biases. But these are the three very common methods, and some of the solutions that should be taken into consideration when we are trying to create an autonomous or an AI platform. Now, let's look at some of the examples for explainable models. Just as I was talking about pathology, this is actually from one of the latest publications of mine in 2021. If you see, this was a particular example. This is OCT images. And what we wanted to do is we wanted to look at the OCT images and classify, is this OCT image normal? Does it have drusen? Does it have diabetic macular edema? Or does it have neovascularization, choroidal neovascularization? And in this case, whenever there was a classifier that was giving us the prediction, we actually went back and we used some of the TF-explain and other of the explainable modalities in order to look at the heat maps. What are the regions of interest where the system is looking for the pathology? And this is the reason why we were able to say, yes, these are the regions of interest where the drusen is actually looking different from where a normal OCT image. And these are the cases that we can then take to the doctors and show them, do you think the autonomous system, or do you think the AI algorithm, is it looking at the right place? And if they say yes, that means that it is on the right track. But if, let's say, there is a certain case where it's a misclassification, there you can actually look at the underlying condition, and the doctor might say that this is actually multiple pathologies happening in this image, and that's the reason why there is a false positive, or a missed detection. So whenever there are outlier conditions, or whenever there are errors, making an explainable system helps explain those errors, and also helps understand if there are similar situations in future, how to deal with them. Now, let's switch gears and look at the top 5 AI failures till 2021. I'm going to give you the top 5 again. This is based off of some of the blogs that I have reviewed, and I'm going to show you how to solve for them, so that if you understand the use case and if you understand the solutions, you will now be better equipped to create your own solutions, or to create your own AI models that have this understanding of responsible AI while you're building them. So the first use case, and this is actually one of the most talked about in the literature for responsible AI. It's the Boston school bus scheduling fiasco in 2017. So again, all of these links I will be putting in the description box below, so that you can read it for itself. But the problem started in 2017. What happened was, in the Boston school district, there were about 600 buses that were operated, and these buses were supposed to take elementary, middle school, and high school kids to their schools. And the schools would all start at 8 a.m. So every day, Monday to Friday, all the schools would start at 8 a.m. And about 48 percent of the parents were satisfied, because again, buses sometimes they would be late, and again, high school kids, there's a lot of pressure on them, so they would not get their full 8 hours of sleep, so there was mental health issues and all of that started happening. So what the city really wanted was there a way so that they could optimize the bus routes, and they could also play around with the start time of schools, so that students, especially the high school students, could get their 8 hours of sleep, and everybody would be transported to the schools at the right amount of time, and the satisfaction would also increase, and the budget for the city should also go down. So what Boston did is they asked a pair of MIT graduate students to build them an algorithm that could do the job. Now let's see what was the process that went through when the graduates were designing the solution. So the first goal the graduates took was to minimize the cost, the operation cost for all of the buses, right? So fueling all of the buses, ensuring all the students are picked up and they are put to their schools. So in this case, if they were just optimizing for the cost, they saw that the whole process could happen if there were only 455 buses, right? And in this case, 56% of the high school students could start later than 8 a.m. So they proposed that if 56% of the high school students started at 9 a.m., but the rest of the students would actually start earlier than 8 a.m. So some students, if middle school and elementary school kids, they start before 8 a.m. and 56% of the HS of the high school students start later than 8 a.m., actually at 9 a.m., then in that case, they could actually have a huge savings of $14.5 million. But in this case, the number of parents went down. It was 37%. Then they looked at maximizing the parents' preferences. Again, if there are multiple kids, if they look at all the different parents preferences that they have, in this case they saw that the number of buses required were 935. So it's way more than what they already have. So they would increase their costs to by 33.5 million, which is way more. And in this case, all of the high school students were supposed to start their school at 9 a.m. So what they ended up doing is they wanted to balance it. They wanted to balance the savings as well as the high school student health. So in this case, 94% of the high school students would start their class after 8 a.m. So at 9 a.m. The number of buses that would be plying would be 480, and that's the reason why there would be a 12 million saving. So this is the goal that they picked, where they are trying to optimize for the savings as well as for the student health. Now, this, however, caused a huge problem, and there was a huge backlash. There was, so much bias into the data that went already, that there were huge number of petitions, parents, signing for it, because there were always households that had one kid in a high school and maybe another one in grade school or middle school, because of which parents, their quality of life just went down the drain, because if one kid has to go to school at 7:15, they have to make sure that the kid goes to bed earlier, and their planning just all goes off. So it was absolutely booted out. Now let's see what are the components that went wrong in this bus scheduling. So first of all, there was definitely bias. So it was not bias free. It was definitely preferring the high school students more than the elementary and the middle school. Of course, the health of everyone should have been taken care, but it was definitely biased more towards the high school student health. So that's the reason why it was disliked so much. Was it explainable? It was, because then it did have the goal and it did have the savings. So, when they picked the optimal solution, they could explain that this is the reason why this is the optimal solution, because it is bringing the cost down, and it is also ensuring that the students' health, the high school students' health, is actually, getting maximized. So it was definitely explainable. But was it contextual? In this case, it was a big no. They did not counter for the quality of life of the parents and of the families that the kids were belonging to. So some of the major issues that happened was the quality of life for kids with elementary and middle school were not catered to. The classes were starting at 7:15, and the parents did not have it at all. There was a lot of group attribution bias, because the features, the goals they were all given equal importance, and high school students were favored more, but there wasn't really an analysis of quality of life for the parents. So that's the reason why it didn't work. So in this case, what could have been some solutions? Some solutions could have been inclusion of features regarding the quality of life, a survey regarding what does a day of a parent typically look like, and if they were supposed to shift the start time from 8 a.m. to 7:30 a.m., what would be the impediment? So ideally the quality of life should also be have given a score, and that score should also have been counted in the goal, rather than just balancing for the cost and student health. They should also have looked at the quality of life. In this case, in 2017, the algorithm that was designed, it was really booed out, and it was never utilized. So it was a lot of resources, a lot of planning in order to come up with the optimal solution, but again, it was a waste. So that's the reason why it is an epic fiasco of an AI system, just because it was not responsible. Now let's look at another use case, and it's the Tay bot, or the Thinking About You bot, that was released by Microsoft in 2016. So this was an AI chatbot. It was released by Microsoft via Twitter. And what it was supposed to do is it was supposed to keep posting or replying to people's tweets. Whoever is tagging Tay, it would respond to them. But what happened was the chatbot, it started receiving a lot of trolling. So trolling means a lot of negative comments and negative feedback over tweet. And what started happening is this TI, the chatbot, it started learning from the negative data. So it was seeing that people are being mean, so it also started being mean. So it started publishing racial and derogatory tweets, and because of which it was instantly taken down. Later there were an updated version called Zoe was also published, and again that was based off the successful versions in China and Japan. However, Zoe also did not make it for a long time, because a lot of people actually said that it was too politically incorrect. So it was either politically too correct or it was politically incorrect in the statements that it was tweeting. So automated chatbots for tweeting has been stopped essentially. However, some of the latest works that is happening in chatbots areas is Jarvis by NVIDIA, where it is trying to understand the underlying context. Now, some of the components of Tay and Zoe. Now, let's look at bias. Now, of course, it was riddled with bias, because like I mentioned, it was learning from the negative feedback that it was getting. I'm sure there were some positive tweets that were also coming its way, but because the sheer number of the negative trolls were so many, it learned to give negative feedback only. So it didn't know how to boost the positive comments way more than the negative ones. So that's the reason why it was definitely riddled by selection bias. And then explainable, well, it was not very explainable either, because in this case, it was taking every single instance as it came, and it was just growing the reinforcement learning system was just understanding or changing its the metrics just based off of every single training data or sample that it was coming at it. So it was not really explainable why it started becoming too politically incorrect or too politically correct after a particular number of samples. So that's why it was not trustworthy in the first place. And finally, contextual. Zoe was somewhat politically correct at times, but sometimes it just completely missed the context as well, because most of the time language is actually just 30% words, but it's more the connotation, the underlying context. I can say something really, and I can say really. So in both cases, in one case I'm really positive and I'm saying really, that's great, and in another case I can be really, so I'm really not sold on the idea. So in these cases, really exclamation or really being happy after that, it's the underlying context is really hard to mine, and that's the reason why context, just using language, is still we have miles ahead of us in that particular area. Now, this is actually a pretty interesting one. This is AI-based webcam tracking, and this happened in 2020. There was this one, soccer camp. What they did is they put an AI system on their webcam so that you would only be tracking the ball. So that the camera would automatically, move itself in order to always make sure that the ball or the soccer ball is within screen. But what ended up happening is that the system confused the coach's bald head with the ball. So what it was doing is, despite it's trying to look for the ball, but then again, it always centers itself at the head, at the bald head of the coach. So in this case, it was clearly not a well-written algorithm, and it clearly had bias. So it was not able to distinguish between a ball and a bald head of the coach. So in this case, bias, definitely. So it did not have the right, again, there is representation bias, right? So ideally, it should have gotten a bald heads example while it was training, so that, it would know that this is not a ball. Explainable, well, yeah, of course. If you again, try to put it through an explainable or TF explain or something of that sort, you will see the heat map. So, and that's the reason why they were able to figure it out, that it was actually getting, confused by the ball head and not just another patch on the grass. So it was definitely an explainable system. So it was thumbs up for that. But again, it just didn't have that negative sample while it was getting trained. And contextual, again, like I mentioned, it is super important in order to have contextual information. So if you had trained it to look for a ball on grass, then that would have been the right context rather than just looking for a ball, because in that case, the bald head would not be appearing on the grass by itself, right? So the reason why this AI failed was because it lacked contextual data. This was actually a very pretty interesting, idea that I found. And again, this is a YouTube video, so I'm going to play it, but I'm going to be forwarding it to show you. So what this is showing is we all have our, iPhones, and which get unlocked by our face. So face detection is used in almost all of the phones right now. So what these, researchers did, they created a 3D printed version of their own head. And they said, it's like a $300. That's all it takes to get a 3D printed head with the color and everything. And with the adequate, poor lighting, what they are trying to do is show this head to the phone and see the phone unlock. So this is just showing you how much loophole there is in this privacy of a of any phone that is, facial recognition based. So I'm just going to play the video here. So here I'm showing you that this is how they are, creating the face, the 3D printed face. And once 3D printed face is ready, they're going to take multiple phones, and then they show the face to that particular phone, and it unlocks. So in these cases, let's look at the components. Bias. Definitely there is bias, and the bias is for different kinds of lighting, because if you have poor lighting, or if you have strong white light at different angles in these, or if you have a masked face, like right now, I try to unlock my iPhone with a mask on, and it doesn't let me. So with masked faces, so there are all these biases that is underlying in these algorithms, because of which all the facial detection systems are not accurate. Explainable, well, most of the time they are, because it's image based. It's very easy to say what are the facial action units, what are the regions of interest where you're looking for in order to say that this is the same person or not. So mostly this was an explainable system, but again, it was riddled with bias. And finally, again, contextual. So ideally, a facial recognition system should never take a snapshot, but it should actually look at the depth. So if you look around, it should be able to see the side features, and be able to get a 3D depth estimation of the feature of your face, and then based off of that, make sure that this is the same person or not. And finally, this was one of the most unfortunate examples, I would say. This is called an AI-powered Genderify platform. So this platform, it actually just had a lifetime of 1 week. It was designed to identify a person's gender by looking at their name, their username, or just email address. So it was just look at your email address and generate metadata. And this metadata would be useful for customer segmentation, for marketing, so based off of your user ID, if it says that you're male, female, or these are your preferences, it will be able to push that kind of products to you. But it was shut down within a week because it has very poor built-in biases. For example, if somebody had the name professor, it would predict with 98.4% probability that it's a male. Or a word stupid, it would return 61.7% that it's female. Right, so it was riddled with these kind of biases, and all because of the training data was flawed to begin with. So again, the components bias, it suffered hugely from selection bias, from sampling bias. It just was looking at bias data to begin with. Explainable, of course, it was not explainable. Like, if you're just looking at names and trying to figure out what gender, it's going to be very hard to explain why that is the case. So, and it completely missed contexts, right? So because doctor or anything else could be a female as well. So that's the reason why it missed all three, and that's the reason why I called it the most unfortunate outcome, because it was riddled with bias, explainability, and context. Finally, I wanted to leave you with some very useful resources around, Google, with Microsoft, as well as with Amazon research around, fairness, accountability. I hope you liked this video, and if you want more such examples of what is more current, please do leave me a comment. Please stay safe, stay healthy, and see you in 2022. Bye-bye.